So we have 3 developers up here. I'll introduce each one of them. On the far right here is Nicholas Savage. He is our managing and sales director for NXP Software, and he's been a longtime partner of the Qualcomm Hexagon program. And then Tatsuya Murakami, he is an engineer with Omron Corporation in Japan. He'll tell you about their products as well. They have a very interesting product solution that has been licensed to OEM. And then finally, Richard Sherastasius. Very good, okay. He is the marketing and sales director for, the DSP software director for Opalum, which offers a speaker enhancement technologies. And each one of them will provide a brief description of their products and their experiences, and then we'll have a time frame for the audience to ask them questions about their experiences. So opening up the DSP is somewhat of a new environment, and it's a different programming environment. So I know many of you might be involved with the program and you're looking for some advanced information on what we've been doing here. I'll try to touch on those, but I'll also try to direct the conversation more to an Android developer and understand how the DSP works in relationship to the Snapdragon platform. And if you see here, we really have multiple different kinds of programming environments. We have an Android SDK environment, which is really focused on Java, scripting languages, and it does have a native and C and C++ programming environment. And then, of course, there is the GUI, or the UI programming on Arduino, and you're focusing on RenderScript, OpenGL, and even OpenCL and other graphic API types of environments. So predominantly, almost all of the development community is focused on the, oops, that slipped quickly. Let's go back. Almost all of the programmers are focused on the Android SDK environment, which is where your Android store programs run and execute. And of course, corollary to that, there's a lot of optimization for the graphics processing. So you'll see almost all the development discussions are focused on these 2 areas here, from a tools and from a mobile application development platform. But there is a hidden programming environment on Snapdragon. It's an embedded programming environment on the DSP. And this is essentially a C, C++ type of programming environment where you'll do all your coding in C, and then you'll do optimization all the way down to assembly level to get the optimal type of performance out of the platform. So this is kind of like an expert programming platform. And what we've tried to do is open up this expert programming platform to a wider audience of developers, and in doing so, make it more accessible and make the features that run on this embedded processing element able to impact the mobile application environment. So we had a session this morning on audio APIs, using native audio APIs, and really what it was describing how, why does this keep moving? I'm not touching anything. Really talking about how I can create features in the Hexagon C embedded programming environment and then expose those into the Android mobile developer environment using native Android APIs. In fact, Google cooperated quite closely with us to enable this to happen. And the primary reasons is that you want the optimization that you get down at the DSP while exposing that to the application development environment. So one of the things that we look at is there's a comprehensive set of features that run on the DSP. All of our speech algorithms, our audio algorithms, and our sensor algorithms are running down below there. And the reason they're running down there is because we can shut down the AP, the display, the CPUs, and in the background, the DSP is constantly running and able to run these. All right, who's got a clicker in there? I'm not touching anything. OK. So the desire for developers to get access to these data types is very intense right now. And what we want to do is be able to make those accessible to those developers. So last year at this conference, we announced our Hexagon SDK, which was a new programming model for the embedded programming environment. In the past, what we had to do was actually release the source code for the DSP and have the developers modify the source code and then license that source code to the OEMs, and the OEMs had to build that into the end products, and that was the vehicle to get access to these data types. Obviously, this is not a valid type of way to create Android development. I guess I'm going to move on. Android development environment. So what we've done is we've created an API-based model where you can call an API to the DSP, and you can download code to the DSP using those APIs and run those natively, even though you're not programming down in that native programming environment. So this is the SDK that we came out with. So this SDK was in basically beta in the past year. In 2013, when we started the program, we introduced the source code model to probably something less than 100 type of developers. We had probably 30 to 50 OEMs and the similar types of third-party developers. Since we came out with the SDK, we've had probably 1,000 different companies take a look at the SDK and evaluate. And we created a sandbox. And the sandbox was essentially our Dragon boards or MDB platforms where they could get the SDK, they could program it, and they could download these features onto the DSP and run them and then experience using these new data types. And based on the success and the feedback that we've got from that, basically what we're planning on doing is expanding the features that we support on that SDK and making it a commercialization route that we can eventually tie to the mobile Android development space. So why would you want to program in the DSP? Essentially, it's a unique kind of processor architecture, a VLIW processor architecture that gives us very high performance and very low power. And the reason that is we have a very parallel operations. We can execute like 4 instructions every clock cycle very efficiently, and we can maintain that very significantly. That means that we basically don't have to run the processor at high clock speeds. We'll typically find an algorithm that runs on the DSP that takes 5 to 10 times the clock speed performance on a high-performance CPU to execute the same algorithm. That can translate into higher performance, or it can translate into much lower power. So in the Google example that I was talking about, Google was playing back music using the CPU, and what they were finding is it consumed too much power. So we enabled them to use the MP3 decoder that we had hard-coded on the DSP. Through APIs, they could tunnel to the DSP and increase the playback time 10 times on the DSP versus the CPU. To give you an idea, a CPU, when you turn it on, you're consuming 100 milliwatts of power just to turn it on. Now you want to do something, you're going to add 100 milliwatt steps. In the DSP, we think of things in about 1 to 10 milliwatt type of steps. So that's kind of the ratio of performance. When you get to the GPU, you think of quarters of a watt of types of power. So we shut off the GPU, we shut off the display, we shut off the CPU, and you're playing music in the background in the DSP in the tens of milliwatt level. I think our MP3 decoder is about 2 milliwatts of power, but when we add up the rest of the circuitry to support that, you get that kind of performance. Now, since we have the DSP, it's been dedicated for audio and speech functions. We also incorporate other use cases like image processing, augmented reality, object recognition, and gestures. So part of what we'll do is we'll be able to hear some partners that have explored new use cases for this. So in the future, we'll be basically extending our DSP processor to support these new use cases and then extending up the API so that the mobile application developers can support those. So right now, we have in the SDK, we have 2 basic methodologies that we allow a high-level programmer to access them. On the left-hand side, we use shared memory APIs using a fast remote procedural call, or fast RPC. What fast RPC is, it's a Linux term of remoting a process, but in this case, we've accelerated the speed that you can do it so that it is not a significant amount of overhead between moving a function of code from the CPU to the DSP. And because these shared memory operations are basically pointing to memory, we can support camera and imaging, computer vision, and video types of operations using the DSP in the SDK today. On the right-hand side, we have dedicated frameworks for these different data types: audio framework, a speech framework, and a sensors framework. And in those cases, we have to find various points on the data path to create a dynamic API that a developer that does not have access to the source code can create a module and stuff it in the DSP between those data points. In the current SDK that we ship, we support audio outputs, but we have on our roadmap supporting APIs across the board for audio, speech, and sensor frameworks. And we hope over the next coming year to announce and release those and make a vibrant developer community that can access all these data path points and create applications that can work always on while the phone is essentially off. What people don't know is their modem is running all the time. And the DSPs are running all the time, and we can basically run these features in the background. And that was the example that Raj Chaluri showed, where he was actually showing the Shazam application in the background. That's basically running in that audio framework when the phone is basically shut down. So we'll see a lot of developments coming in the SDK today. So just for those that are not familiar with it, here's a quick look at what the SDK is. Essentially, we have our tool chain, C-code tool chain, and we've augmented that with a set of libraries and a runtime environment that we can use fast RPC and dynamically load these code modules. I want to announce that the next version of the SDK will switch compilers. We've used GCC compilers for the history of the program. We'll be releasing an LLVM version of the compiler in the next version of the SDK, which is very significant for us. It's like a building block to create a more uniform, heterogeneous programming environment where the CPU, the GPU, and the DSP are all using the LLVM compiler technology. So we can focus our optimization and performance efforts on that compiler, and we can also use intermediate LLVM code to dispatch code to different processors depending on the requirements that it has. One of the things that people probably don't realize is if they've downloaded our fast computer vision SDK off our developer network, that has libraries on the ARM and the Neon processors. But within the DSP SDK, we have assembly optimized versions of all those libraries running on the Hexagon DSP. And we have customers that will run those libraries, and they may run some on the CPU and some on the DSP, and you won't know it. They'll mix and match it depending on the relative performance or the power that they want to achieve for that. So that's a very interesting capability. The sandboxes I talked about before are these Dragon boards and development boards. We have we go to intrinsic.com website, and you can download or order those boards, and also we'll enable downloading the SDK and the advanced features of the SDK on that. And then finally, we have examples that show how you link your Android type example to the DSP using this SDK. So as part of a development community, it's important for Qualcomm to kind of get out of the way and describe what they're doing with this platform. And the more developers that take rich advantage of what I call the engine room of the Snapdragon platform, the high-performance embedded programming environment, the more differentiated products we've got. It's kind of a hidden secret that our 30 top OEM customers extensively use the embedded programming environment to modify their features. Almost every major phone platform has significant modifications to the DSP, either to take the OEM's own features and incorporate them, or by partners that I have here, they've actually licensed those features to OEMs, and they're embedded and hidden in the products. And I'm really not at liberty to tell you what those products are because it's confidential. I'll allow them to decide that. And kind of this is a good segue to bring Nicholas Savage up. He can describe NXP Software's experience on the DSP. No, you're welcome to ask questions. You want to have questions now?
Yes.
Okay.
So a quick question on, first of all, you're working for Bosch Sensor Tech, so I would focus on the sensor side. And you had one slide where you mentioned that sensors would be enabled during the coming year. Mm-hmm. There is two parts into enabling sensors in this kind of architectures. There is the low-level drivers, and there is algorithms.
Right.
Will we be able to do both with the SDK, or it's actually more on the algorithm side?
We're looking at supporting both. We're actually probably going to support the drivers first because what we have, essentially, there's been an explosion in the number of sensors that got on a platform. And right now, our sensor team, I think, supports 17 sensors in its standard build. And what a lot of the OEMs want to swap out those sensors with other sensors that they prefer or add additional sensors that they want to. A lot of these Snapdragon platforms are in the wearable products, and one of the key things about wearables, how do I optimize the sensor subsystems? So one of the first things we'll do with the SDK is allow with the SDK for you to create a driver and be able to breadboard it on one of the Dragon boards and bring it up, and now you have a programming environment for that. The algorithm is a little bit more complex for us to integrate, and it's going to probably take longer, but we see huge value because we see a lot of companies want to integrate sensor and audio or sensor and speech to create, hybrid kind of solutions that create even more contextually aware solutions. So I hope to be able to announce in the coming year the availability of both of those capabilities.
Okay. And sorry, just a quick follow-up question. So on the algo side, it happens that some algos are too complex to really run on the DSP, and you want to split them between the AP and the DSP. Would that be possible and supported?
In fact, we recommend that. In fact, you've got a lot more horsepower in the CPU, but you only need to do that when you have the phone up. So you could have calibration, compensation, and data collection activities running in the DSP, it'll trigger an event, and it'll trigger either something sent to the cloud or to be processed on the CPU.
Okay,
Yes.
thank you.
The first CV is supported for Snapdragon 600.
Yes, it is.
So you have the first CV library for
That's correct, yes.
Point DSP.
That's correct, yeah.
How much time does it cost to move from the Android space, I mean from the Java to the DSP? I mean, does it affect the latency of the audio running?
Actually, you know, audio on Android is actually a sore point of audio. I think you're in the 80 to 100 milliseconds, and I'm being complimentary to Google with those kind of numbers. We can get, you know, 10, 20 millisecond latency using the DSP, and in fact, we have a low latency audio solution by using the DSP itself. And one of the first things we want to do is enable mobile application developers to use you know, the dynamically loaded code of the DSP to create mobile Android apps that have low latency audio. The fast RPC mechanism is in the microsecond time frame. So it basically eliminates you know, typically we're worried about millisecond latency in audio, and the transport layer between the CPU and DSP is an order of magnitude faster than that.
Okay, thanks.
How do we get access to the Hexagon SDK?
It's available at developer.qualcomm.com. You search for Hexagon. It isn't available for direct download because we've had a tremendous interest in Eastern European countries and others that want to get into your audio and mess with the security. So we have a little screening process, but it's very easy to make it available. Yes?
So is it possible right now to build a product using Hexagon and ship it ourselves, or does it have to go through an OEM to get out?
Currently, it has to go through an OEM. The reason is a security issue. Again, when you drop a code module into the DSP, you're into data types that are confidential, and there's no way to prevent a developer to get the SDK, create an undesirable DSP program, and bypass all platform security and compromise the platforms. And what we didn't want to do is have this program create instability or security risks for our commercial customers. So we created a sandbox on the SDK that you can use to go demonstrate to an OEM, and then an OEM can build it in. What we're working on this year is putting in security domain protections on your code modules that run so that we can eliminate that, and you can have a commercial Android app that can download directly to the DSP. So we're just waiting to implement some security procedures to open it up.
And so by SDK, that really means a future chipset?
That's,
Does that mean an actual SDK we can build with and then deploy on existing platforms?
the future, you'll need basically.
Steve, could you repeat the question?
Oh, I'm sorry. So the question was, do I need to wait for a future chipset, or do I need to wait for a new SDK to become a mobile application developer that uses the DSP? It'll be on a future chipset roadmap because we have to change the binaries on the DSP to enable the protections. And then what we'll try to do is backport those to other chips, but it is a chipset type of limitation. I think we should go on to the speakers so we have enough time for them, and we'll all be available for questions after the session as well. Sorry, Nicholas. Go ahead.
Yeah, thank you. My name is Nicolas Sauvage. It's very nice to be here. It's working. And to see friends from nearby California all the way from India. It's very nice. We started the partnership with Qualcomm. Actually, we started the discussions back, I think, in 2011 with Steve.
Yeah, it's been a long time, yeah.
Yeah, and it took time to mature into something that you see today, and the dynamic loading is really exciting. But we went step by step, and I think we learned along the way. From our experience, our first product shipping on the DSP with an OEM was a Samsung Galaxy Note 2. Just for giving a feel for when it started. What I would like to do is to introduce very quickly NXP software so that you know it's a software-only company. So NXP sounds like NXP Semi. It's our mother company. But we are the entity that actually only develops software-only solutions. What's very interesting about what Steve just presented is you have seen three frameworks. One is audio, one is speech, and one is sensors. We've already worked with the first two, and we're excited to start on the third one soon. I think we can skip this one. So what are we excited about at NXP Software? We're excited about what actually people care about. one of the first is, of course, physical health. What can we do to make people more healthy? Because at the end, this is what really matters, your family, your friends, yourself. Mental well-being, also extremely important. How can we feel better about ourselves, about others, and make sure that we are in a harmonious community? Safety and security, I mean, it's becoming nearly every day there are issues about security, about safety. The previous session was about security, where apparently in London now 49% of the crimes are about mobile devices related. So clearly we need to do something about it. And part of it, for example, could be biometrics linked to the voice, the speech, and then connections to loved ones. I think that's basically why we work on our products in NXP software. Anything that relates to these themes. One of the things that's very exciting about DSP technology is a very low power aspect to it. You can be always on. And I think that some of the developers here will be very excited to have something that can turn all the time, always on. This is our view of the world. More human, more you. At the end, the device is always with you. It follows you. It knows way more than probably sometimes it should, but it knows where you've been. It can listen. At some point, the microphones will be able to listen all the time. Of course, the user needs to say, yes, I want to, but there is so many things you can do when the sensors are always listening. Today, the microphone actually is not always on. But imagine what it could do if it was always on. And here the idea of more human, more you is that the more we can bring technologies that actually add value on the human side, the more the device becomes an association to you. So this is one of our first products, our traditional product. That's the one that I mentioned was starting shipping in Galaxy Note 2 with the Hexagon program. And it's basically noise suppression, echo cancellation, voice intelligibility, and voice quality. And today, if I have to be honest, we really focus a lot about voice intelligibility and voice quality. We believe that actually the more you can get quality out of a voice call, whether you're holding it like this, or you're holding as a speakerphone mode, or it's 2 meters away on the table, it matters. What we loved about the Hexagon program, and I think I can reveal this, we were the first ISV to start on the speech side, and it was very difficult at first. I think this is part of a partnership. You have to help each other, and I think that was an extremely good partnership. Of course, we had Samsung also helping us to mature this. I think today the Hexagon program is extremely mature. It's fantastic. Integration, development, deployment, support really has improved. To give you an idea, yesterday we just made a press release that we did a project on the Hexagon program with ZTE for their flagship, which is called Nubia. And from start to mass production, it took 6 weeks. And you do know that the software freeze is actually not on the day of the mass production, so it was shorter than 6 weeks. That would not be possible if we had to do an integration like we used to do in the past. So I would really say that the Hexagon program is really, really mature. And it's exciting because I think all the learnings from what we've learned on speech, we can then apply on the sensor framework. So that's some of our deployments of the last quarter. I just wanted to give you a feel of where it's deployed and which OEMs, because at the end, I think for you developers, it matters to know which devices are using this Hexagon program. So here you have the Galaxy S5, you have the LG G3, Huawei LTE, the latest, ZTE Blade, and the Nubia I just mentioned, the Z7 Max, which, if I am correct, this is the one that the First Lady of China decided to use as her own phone, switching from iPhone to that phone. So in China, it's a big deal. I think that's it for the slides. So I'm not sure you want to take questions or...
I think we'll go each member, and then we
Okay.
can take questions as a group. Yeah. Tatsuya?
Okay.
Yep. We'll do question. That's not me. Okay, there we go.
Okay. My name is Tatsuya Murakami. I appreciate the opportunity to speak with you today. So we are Omron. The headquarters is located in Kyoto, Japan. We have image sensing technology, including libraries for face detection and face recognition. So please, next slide. Awesome. So we call this technology Okao Vision. So Okao Vision software library is embedded in mobile devices, and especially face detection is using various applications. For example, camera preview, editing photo, and searching people from photos. And on the other hand, battery life is always a critical issue for mobile devices. So there is a strong demand for power consumption improvement in order to achieve longer usage with mobile devices. So first, we looked into porting for ARM, but we reached a limit for effective performance on ARM. So we worked in cooperation with Qualcomm DSP engineers for power consumption improvement. And so the following three methods. One is multi-threading support by DSP hardware threading. And number two is cache efficiency improvement through prefetch. And number three is optimization through assembler, including VLIW and hardware loop. So this is result. We were able to obtain better processing speed, the DSP, compared to the ARM version. So ARM porting is 35 milliseconds, but DSP porting with full optimization is 21 milliseconds. So we were able to achieve power consumption reduction of 125 milliamperes. So this is the last slide. A future project. We can provide our customer with our various libraries. For example, face recognition and gaze estimation, age gender estimation, and Okao beautification or eye enlargement and face reshape. But we have yet to optimize performance with our these libraries. So we are looking for new ways to improve quality and performance. So I think the DSP porting is a good way to improve performance. Thank you.
Thank you. Oh, thank you very much. That was very good.
Do you have my single slide ready?
It takes him about 15 seconds.
Yeah, that's fine. Well, while that's happening, let me just introduce myself. My name is Richard. I am the DSP software director of Opalum. And I imagine that some of you may never have heard of our company. So let me start by saying that we're a Swedish audio technology company, and our mission is to bring high-end audio out of constrained devices. And when I say constrained devices, I mean basically any device that is either acoustically or otherwise physically limited, or, for example, constrained by power or any other constraint, really. And we do that through both hardware solutions and software solutions, although our hardware solutions are more intended for non-mobile devices. It's more for larger standalone applications that are not really the focus here. So I'm going to be talking mostly about our software algorithms. And when it comes to our software algorithms, we have been working with the Hexagon SDK for about a year and a half. And to be honest, when we started out a year and a half ago, it wasn't an entirely smooth process. There was quite a lot of legal documents to go through, and it took a while before we actually had all the tools and the code that we needed to get running and start actually working. And I know for a fact that has changed greatly today. I had a company that we were potentially partnering with in June of this year, and from our first meeting with them, where I explained what they needed to do, what tools to download, etc., to when they had a first version compiled of their library that we could potentially also integrate into our library. I think it was about 4 days, which is an exceptional improvement to how long it took for us to get started. So if there is, has ever been a good time to start with Hexagon development, I think the time is now. And going back to the algorithms that we actually provide to our customers, unfortunately, I can't tell you any devices that we're in because those are not on the market yet. But we are working with OEMs, especially when it comes to boosted amplifiers and speaker protection. And the goal there is to sort of enable OEMs and device handset manufacturers to get an audio output quality from their handset that is as good or better as they would get from a small standalone, for example, Bluetooth speaker, and effectively eliminate the need for those small devices, so that you're good to go with just your phone. And thanks to the collaboration that we have done with Qualcomm and also working with the SDK, importing, making sure everything works inside the Hexagon, we're right now actually making sure that that is a possibility, a real possibility for OEMs. Right.
Thank you, Richard. So I hope the intent here was we have, somebody delivering speech for quite a long time who from my perspective, it's been successful because they've continued to invest in the platforms. And then a use case that typically doesn't run on the DSP, facial recognition, where we actually were faced with the problem where the initial goal was just to put it on the CPU and they were done, and the OEM came back and they said, this product is not meeting our specifications. And then we went through this optimization process. And finally, a new company with, well, I wish you brought the demo. It's really exciting. It's like having a boom box that's coming out of your phone. It's a very impressive demo. It's going to transform, I think, audio in mobile devices, and we see a big trend there has happened. But the objective here is to see if you have any questions for the panel on that. Maybe I'll kick it off with a question. You go down the road. Do you think this is a way to make money? And I'll start with you, Nicholas.
Okay, I think that makes sense because we're already making money.
Well, you were the one that was probably making more money than everybody.
So I think in terms of return on investment, because at the end it's a lot of efforts, but definitively the OEMs are very appreciative when you bring your solutions as easy as possible for them to take in. I think that has been fantastic. I think all the deployments we've had have become easier and easier, both on our side and to the OEM side. The example I gave about ZTE Nubia, 6 weeks from start the first meeting to being deployed, that's I think, amazing. Actually, where we are in pain today is on the platform that doesn't have the ADSP, this multimedia DSP. So here I know that we are working hard to find mitigation plan, but it shows that actually there's a lot of traction, and even the OEMs, not just us, want this back. They really want to have this ability to have solutions running on this Hexagon program. and the DSP. And it's not just for power consumption, it's also for flexibility, it's for being able to adapt to new use case very quickly. So on the revenue side, I think that, yes, you can make money, and I think with Qualcomm's traction and pushing the innovation envelope, you really get market potential, yes.
Make money?
Well, I mean, is it, I guess it's really a question of not necessarily making money, but the opportunity versus the cost. And what's your written reflection of that? Yeah.
I think using DSP is very strong effort to us. And actually, we achieved to get power consumption improvement. So I think to take a cost is okay to us.
Yeah, I think in your case it was there would be no revenue without meeting the product specification requirements, and when you're unable to meet that on the CPU, the DSP made sense. I think from our perspective, there was always some critical use cases like that where you could afford to invest a lot of money in optimizing the feature with it. The goal here is to reduce the cost to do it so that it widens up to maybe a lot more applications that can't bear the expense. Now, if you have an expensive product you can sell to a company with 100 million units, you can afford a lot of development. And I think that's how we started out. What we're trying to do is drive this availability of this embedded platform, not where it takes hundreds of thousands of dollars to develop a solution, but in the thousands of dollars to type of a solution. And then you don't need to necessarily generate so much revenue to offset that. Richard, what was your guys' experience?
Without a doubt, I'd say the answer is yes. Considering the presence that the Snapdragon chipsets have in the handset market, I mean, even if you're doing something and there is, of course, development costs associated with porting any software to a DSP that might be quite specialized, but seeing how common these chipsets are at manufacturers, I don't know if there's a better platform to target if you're going to choose just one. So for us, being a small company, if it hadn't been for the fact that we supported our algorithms running in the Hexagon, I'm not sure that we would have gotten the deals that we did get, because the manufacturer, the OEM, didn't have to get another chip. They're trying to save real estate. They don't want to have more chips on the board. They want to have less chips. So the more features that they can actually pull into the main chip, the better. And that's what we're seeing as well. So we're essentially trying to replace several of the functionality that they had in external standalone chips by pulling that functionality into the Hexagon DSP. And for that, it has been integral for getting deals at all.
Great. Yeah, and I think part of the thing we would try to do is make a common platform. So if you had created a product on a specific chipset for an OEM, suddenly that software solution works on all of our chipsets in all of our markets, not just smartphones, but tablets and automotive and IoE and in the wearable devices. Because essentially all the wearable devices, I think every device that you've seen today, like the new Fire tablet that was announced, the Fire TV that you've got in your backpack, the wearable watch, the smart gear watch, the automotive solutions we've got, basically they use the identical processor, tool chain, RTOS, and frameworks that I talked about. So once you get a solution working with these APIs, the goal is you can scale it across all these platforms. And if we can't do that, then we can't really enable the mobile Android development environment. Because one of the things that we do know is that if you have to make a specific version of your app for Snapdragon or for one chipset, it just doesn't work. So that's why what we're going to do over time is create this ubiquity of these APIs. They'll be native across Android, across Windows, across Linux, across BlackBerry, so that and across all those product segments I talked about, so you get that type of leverage off that product development investment. Are there any other questions out here? Yes. You can talk right at the mic here.
I think this is the question for the panel, really. I wanted to know about your experiences from the security point of view. How do you, protect your IP and on the QDSP or Hexagon?
I can go first, if I may.
Yep.
I would say that developing and delivering software to a customer, if you're afraid of your IP sort of getting compromised, that's a risk at some point you have to be willing to take when you deliver software, because no matter how difficult you make it to reverse engineer, at some point it has to be able to run. And if it's possible to run the code as intended, then someone with time and skill will be able to reverse engineer it. So I wouldn't say, if you use the tools, and for example, when you're compiling Hexagon libraries, you can always strip them to remove any debug symbols and remove symbol names that you don't need to have externally declared. But in the end, at least for us, we think that it's better to spend time to have a product that is better than your competitors than spending time and spend time on developing that product and making sure you stay ahead, rather than trying to protect what you have today, because in the end you're probably going to be fighting a losing battle anyway, because someone with enough time, if they really want to, will be able to reverse engineer it anyway. At least that's my point of view.
Maybe I can give a comment, because most people are worried, especially about China. I spent a lot of time in China, and maybe 10 years ago it was true, there was these horror stories about one employee leaving to go to another company with a DVD or CD. That's not true anymore. I mean, if I look at the mobile device OEMs today, they're extremely respectful and careful about your IP. And the stories that we had in the past are no longer true. So I totally agree with Richard. I think it's about speed today. And these Chinese OEMs, because I'm talking about China here, they want innovation as fast as possible. They want to push the envelope. It's no longer about BOM cost reduction. It's actually about how they're going to innovate and how you help them contribute to that. So we are very careful about our IP. We are a software company. We really care about it. But we have customers today who are extremely respectful of that. So I think it's good you have your checkpoints and you're careful about it, but you should worry about actually contributing on the innovation path much more.
Yeah, I agree 100%. Our experiences with OEMs in China, for example, they're exactly the same. They're not after sort of reverse engineering your solution. They just want to make sure that they get the best solution to market before anyone else.
I think that speaks to the pace of the mobile business. I mean, our chipsets are coming out so fast and the innovation is so fast that if you're trying to reverse engineer, you're reverse engineering last year's model while everybody else is shipping the new model. Now, the other OEMs are pretty respectful because they don't want their competitors to get the features either. But when we go to a mobile Android environment, we think there are some maybe concerns there, and we're looking at incorporating some security into the platform so that it'll work everywhere, but it can't be taken and used everywhere that it wasn't authorized by the author. Yeah. If there's not any other questions, I'd really thank everyone. Oh, you got a question? Yeah.
I was wondering if you guys could elaborate a little bit on your experiences optimizing your software and using the tools that Qualcomm has provided. And then also, Steve, if maybe you could talk a little bit to your plans down the road to integrate timing profiling a little bit better for the Hexagon into the existing Qualcomm tools.
Okay.
Well, I think you can cover a number of things. I just want to mention about, for example, MIPS, where we really work hard to optimize depending on the segment of the device. So, for example, at the moment, we're looking at working closely with OEMs for a platform that actually doesn't have an ADSP, so it's a bit separate from the Hexagon program, but we want to fit in the budget so that actually we don't compromise anything in the modem. And we've managed to do that. And I think that that was made possible because we have all the experience beforehand on the Hexagon program, and the tool chain is the same, and everything is the same. And I think that that would not have been possible without all this experience in the past. So what I would say to the developers is, the more you are getting experience on the Hexagon program, the more actually you can experience and experiment on these optimizations. The obvious one is power consumption, but I'm sure other panels can comment on that.
We have experience putting on DSP, and we try to other functions supporting DSP, and we can get good result. And we are hope to expand our business with DSP. Yeah.
You done?
Yeah.
Yeah, what I would say is that the Hexagon SDK provides you with basically the tools that you need. It's quite easy to, and for all the audio, for example, those are the ones that I have experience with. But I guess most of the examples in the Hexagon SDK will also come with test applications, and they're quite easy to modify to fit your needs. And then you just run them through the profiler, and you will get a result of the actual resource consumption for your program. And you can also, I don't know if they're well documented, but there are actually things you can do to make the profiler run differently. You can simulate higher level of cache misses and everything. So it's a very versatile and powerful tool that you can use to optimize. And I mean, using that, we have been able to optimize our algorithms a lot before even going to the customer, so that when we went to the customer to demo, we already had our performance at a level where they were comfortable saying that there is enough sort of free resources in their platform to fit our algorithm. So I would say that everything you need to make a very optimized program is all in there, and you also get full documentation for like intrinsic operations and stuff like that. And it's quite easy to, even in the C coding, you can make great improvements just by using those.
Maybe I have one more comment, because sometimes developers focus on optimizations. I think you need to focus on speed. And this dynamic loading that Steve is introducing in the Hexagon program, for me, is a dream come true. It means that very quickly you can allow OEMs, if that's what you do, that's what we do, but it could be also on the apps, but you can experiment much more faster than before. So if there's one thing you probably should consider optimizing first, is speed. In a way of lean startup, you deliver first an MVP, you test it, and the dynamic loading allows you to do that on a day. You can get the feedback, then you can learn what's not quite right, and then you optimize. So I would say that optimizations are important, but try not to put them too much in the forefront of your planning. Yeah.
Well, thank you, Adam. We ran out of time. I appreciate the participation, the questions, but we can't run over here. So thank you for coming. If there's some water bottles in the back, if there are any left for you, and I'll answer your question offline, Adam. Thank you.